In this video, we'll use factorial and double factorial to generate the Taylor-Maclaurin series sum of NORMSDIST formula, which is in the form of square root of pi times the quantity negative 0.5 times NORMSDIST of x of times square root of 2, and the value of x is from negative 2 to positive 2. We begin with the formula of this series sum expansion, which is the summation of a times x to the power 2n plus 1, where a can be a1, which is the factorial, or a2, the double factorial. And the value of n is from 0 to infinity. You can start from 0 up to infinity. 16 is good enough. We continue with the factorial coefficient. So array formula, minus 1 raised to the power n. That's the numerator. Divided by the denominator has two parts. The first part, factorial of n. That's the first part. The second part, the quantity 2n plus 1. So times 2 times n plus 1. And here's factorial coefficients. Next, we continue with the double factorial coefficient. So array formula, minus 2 raised to the power n. That's our n. Times. The second part is double factorial. So factorial to fact double factorial. 2n minus 1. So 2 times n minus 1. That's the numerator. Now the denominator, which is factorial of 2n plus 1. So factorial 2 times n plus 1. And enter. These values are exactly the same. We'll correct this first item using the if statement. So that is if n equals 0, then 1. Otherwise, calculate. Now their values are exactly the same. We continue with the expansion, which is our formula, series sum of the x values raised to the power 2n plus 1. 2n plus 1 starts from, at n equals 0, 2 times 0 plus 1, 1. So it starts from 1, followed by 2 times 1 plus 1, 3. So 2 times 2 plus 1, 5. 1, 3, 5, 2 times 2 plus 1, 5. So 1, 3, 5, 7, 9. The interval is 2. And the coefficient, we can choose the factorial or the double factorial. Let's start with the double factorial. I will chart this. I will use scatter chart. Scatter the chart, use row 1 as header, and show the trend line. Series, trend line, polynomial to the 8th degree. For the label, use the equation. For the legend, position at the bottom. So here's the trend line and the polynomial of the expansion, which is also known as the Gaussian integral. Now we continue with the NORMSDIST formula. Start with the NORMSDIST function. Array formula, NORMSDIST of the x values. That's for now. We don't have the polynomial, so we edit the chart. Edit, customize, series, trend line, polynomial to the 8th degree. Use the equation as label. We'll calculate this polynomial regression coefficient using LINEST. To do that, we complete the LINEST matrix. So, starting with the power, this is equal to transpose 0 to 8. Now the elements of the matrix, which is array formula of the x values raised to the power 0 to 8. Now we can use LINEST to calculate the polynomial regression coefficient. So LINEST data y and dot x. And for the NORMSDIST, LINEST dot y and dot x. Next, we modify the NORMSDIST to match to the Gaussian integral. So we will factor in square root of 2. So times square root of 2. Next, we factor in negative zero point 0.5 plus. So minus zero point 0.5 plus the NORMSDIST. Getting closer now. Finally, we multiply square root of pi. Square root of pi to the quantity. So times the quantity. Now they're all in the same trend line and the polynomials are the same. So we will compare the polynomial regression curve, starting with the the coefficient of x to the 0, 0. Coefficient of x, 0.997. Coefficient of x squared, 0. Coefficient of x cubed, minus 0.313. Coefficient of x to the fourth, 0. Coefficient of x to the fifth, minus positive 0.0696. 0.0696. Coefficient of x to the sixth, 0. Coefficient of x to the seventh, minus 6.54 times 10 to the minus 3. Coefficient of x to the eighth, 0. That's because we're using the double factorial. That's a double factor. Suppose we use the factorial coefficient. So erase this, replace it with the factorial coefficient. We still get the same polynomial regression coefficients. The polynomials are the same, our trend lines are still the same, and the datasets, they're still the same. This completes the use of factorial and double factorial to generate the Taylor-Maclaurin series sum of NORMSDIST form equation or NORMSDIST formula.